So in this video, we are going to look at a few more examples of derivatives with e to the x and ln of x. So just as a reminder, before we do that, we need to remember what is the derivative of e to the x and what is the derivative of ln of x. So the derivative of e to the x is always itself, so it's e to the x. And we said that the derivative of ln of x is equal to 1 over x. Okay, and just note, because one of the homework assignments has this, if you have the absolute value of x, that derivative is still 1 over x. It's just this domain is x is greater than or equal to, sorry, greater than 0. And this one, the domain would be like all real numbers, except x cannot equal 0. And this is the symbol for all real numbers. So it just changes the domain, but the derivative is the same. Okay, so we're going to look at a few examples. So we're going to apply those rules we learned about derivatives, the constant multiple rule, and then the derivative rule for sum and differences. So the derivative of 6e to the x, we use that constant multiple rule. So we write y prime equals, and then the constant stays in front. And then the derivative of e to the x is just itself. So you still get the exact same thing when there's a constant in front. And then the derivative of 4e to the x plus x squared minus e, that's kind of the same idea. I'm just going to take the derivative of each term. So the derivative of 4e to the x is 4e to the x. Okay, so we keep the constant in front and we take the derivative of e to the x, which is e to the x. The derivative of x squared is 2x. Now, be careful with this. This is minus e, but there's no variable. So this e is that constant number of 2.71, and it goes on forever. So the derivative of this e is just 0. Okay, so the derivative of e in general is equal to 0. Okay, and technically it should be minus 0. It doesn't make a difference. So this derivative is just 4e to the x plus 2x. Okay. So just be careful, derivative of e by itself, no variable, is 0. The derivative of e with the exponent of x is itself e to the x. And then for just one more example, because this will help with the application problems for e, is if you have the derivative of e to some function of x, so like e to the 2x or e to the x squared or something where it's not just x here, we have to use a special rule. It's called the chain rule. Right now, we're just going to look at it for e, and in the next module, you'll be looking at applying the chain rule to a lot of things. So for this, if we take the derivative of e to a function of x, what it is it's itself, and then you multiply by the derivative of that exponent. And so it's always itself, and you multiply the derivative of the exponent. So for an example, the derivative of, let's say, e to the x squared, okay? So it is itself, e to the x squared, and then we multiply by the derivative of the exponent, which is 2x. Okay? And usually just in math, we usually put the 2x first. It's just a little bit cleaner, but it really doesn't matter the order. So for another one, if I said like e to the 4x, then when I take the derivative, it's itself. And then we multiply by the derivative of 4x. So if I write this out, the derivative of that inside, and that gives me the derivative of 4x is 4. So it's times 4. And again, we usually put that in the front. So that is the derivative of an exponential function to some function g of x. And those, we'll do more examples with e once we get into more rules.